Ladies and gentlemen, our first talk this morning is from Sylvia Piefer. Sylvia is an open source video technology enthusiast with a long background in open source software, media technology and development, and open standards as well. She has a PhD in audio and video content and analysis and has worked with research institutes. Started her own video technology company, is a freelance web and standards developer, and is currently a Google contractor working on the W3C video standards and Google video technology. She's been one of the key drivers of video accessibility, specifications in HTML5, and the author of the definitive guide of HTML5 from APRES. Sylvia, over to you.
Thank you. That sounds a lot bigger than what I do. I just, try and get new stuff working by fiddling around with it. So today we're actually talking about one of those moving targets, new technology, which is video conferencing on the web, called WebRTC. Right, let's just go right in. I've already said everything about me. There's not much more to say. There's a picture of my book, and don't read it because half of it is out of date. Maybe the first half is still useful. Anyway, today we're talking about the part that in my book is utterly useless. So we're talking about WebRTC, and I'm talking about the latest spec, which has just gone and become a extension spec at the W3C, extension to HTML. So I'm hoping that the moving target thing is slowly starting to stop. Like, finally we can implement actual applications towards it. Because the last time I gave this presentation, which was a few months ago, I already had to change it from the first time I gave this presentation. And this time I had to change it again because it stopped working again. But that's what this is all about. We're trying to make it work, and we're trying to make it work across browsers. And I'm very happy that I can today show off two browsers that are doing WebRTC. That's Chrome and Mozilla. And some part of it which is actually implemented by more browsers. So enjoy. Video conferencing is hard, right? There is all these different things that you need to think about. There's codecs, there's echo cancellation, there's gain control, noise reduction, etc., all the networking stuff, jitter buffers, error concealment, and then the session negotiation and so on and so forth. But so to the normal user, that's just, oh my God, that's just too hard. So hopefully we don't have to worry about any of this anymore, or most of it, and the browser will do it all for us. So we're taking it step by step today. I'm going to show you the key elements that enable us to do video conferencing on the web. One is the MediaStream API, which allows us to access local devices. I'll assume the first one, creating video elements, because I've talked about that for 3 years now. Everyone is already familiar with. So the second one is the MediaStream API, getting access to your local camera, your webcam, whatever camera you have locally, your microphone. Then you want to display that locally in your video element. That's done by a thing called create object URL. So you use the data coming from a device, create a URL, and plug that into the video element. And the last part, which is admittedly the hardest part, is to set up your session and then have the peers talk to each other. But what we get is amazing. It's plugin free video conferencing in the browser. And that's where we're heading, and that's what really is the core of my message today. We will have plugin free video conferencing at your fingertips for everyone, with maybe not 3 or 4 lines of code, but with a few hundred lines of code, and you'll be up and running. Anyone can do it. That's just amazing. So time for a demo, because of course I've talked too much. All those people who've got a laptop in front of them and have Google Chrome installed, please go to that URL, apprtc.appspot.com. don't connect to me, connect to a friend. So send the URL that you're getting in that when you've got there. Because I'm on my own little subnet here, so I'm sort of a little bit away from you. I don't want to get, you know, all the interference. Somebody's sharing music. So you're getting, what's going to happen? I got rickrolled, yeah! So what's going to happen is, yeah, slowly. My internet is a little slow. Sorry? No, not yours. This is Google's thing. You're getting a browser window, and it's going to ask you to access your local device. So you gotta, of course, allow it, otherwise you won't get a connection. And then it's going to display the video of your local video webcam, right? Then you get a URL at which one other person can join you. So send that URL to a friend, and they do the same thing, and then you can talk to each other. Do it to someone in another room, and we can watch the video from the other room in here. I don't know why I'm not getting absolutely nothing. Yeah, my internet here isn't good enough. So share your URL and the source code. This is what I've based my demo on here. The source code of this application at AppRTC is up at Google. It is also the most updated source code for doing WebRTC. So if you're ever going to want to implement something and something's not really working, check out that source code and see how they're doing it. At some point it's going to interrupt me. So we'll do it in steps here. We'll replicate this. So the first thing we need are two video elements. One for the local video and the other one for the remote video, yours. Easy enough, that's the code. Yeah, I thought that might happen. So that's the code. Put it on autoplay so you don't have to press play in order to get your remote stream playing. It will just work. It's the easy part. The second part is still fairly easy and actually implemented the same across browsers. It's called Get User Media. This is the one that gives you local access to your local device and display. So even that is really small amount of code. You have your video element, you get it in JavaScript, get element by ID. You use this Get User Media function. You tell it what you want, audio and video, and what function to call when it succeeds. When it succeeds, your video source gets the URL from that stream. Easy as that. So I hit start. It asks me if I want to allow it to access my camera and microphone. I say allow, and if it all works, we got video. There you go. That's my local webcam. Yay, first step. Just to show you. Nope. Exit full screen. This also works in Firefox. What's Jeff doing?
Better lighting.
Oh, okay. Right, this is Firefox nightly. And in nightly you don't have to do anything, it just works. Start video, gives you this dialog. You allow it to do it, and yay, it works in Firefox. Opera does it too. Maybe we'll wait a little. So this is great because this is implemented across several browsers and interoperable. So you can, what's interoperable when you're just getting your local device? But what it means is that all of them follow the same code, only with slight little differences. For I'm mentioning this here already. For getting peer connection running in Firefox, you need to have some other things set up in about config. But enabled is this thing that activates the get user media. And in released Firefoxes, you have to set it by hand. In Nightly, it's already activated. And some of the interoperability isn't fully implemented, so some of them use prefixes. So it's WebKit get user media, it's Moz get user media. Opera has no prefix. Microsoft also has MS get user media, but because they all follow the same pattern, so it's fairly solid now. I think we'll see the prefixes being dropped fairly soon. Right, you've seen the privacy alerts. They all look different in the different browsers. So Chrome asks you permission in a bar at the top. So you have to say allow. Firefox makes this drop down. And it can be, Firefox depends on how you implement it. It might do just the video and then just the audio. So you get 2 pop-ups. And you have to say, OK, select these devices and allow them to connect. In Opera, there's a drop-down also from the browser bar, and you can say allow once or allow always. That's really nice, the allow always, because it won't bother you ever again. Cool things you can do just with get user media. I wanted to show you this, but I don't think the internet's good enough for me. So this one is an app that just uses your local video camera input, finds your face, and then puts funny things on top of them. So that's pretty cool. And that's all done in HTML5. So there's no plugins, nothing else. Very cool. This one is an augmented reality one. What you do is it gets your video, and then you hold up something like that in front of the camera. And this is an area that it then replaces with slides. So you can show your photos from your photo collection by just holding this up and going left, right on in your video. It's kind of cool, and thinking about it when you show your photos to your friends via peer connection, I think it has some merit. The xylophone one is also recognizing your finger movements, and you can actually play the xylophone just by putting your fingers in the air. Yes, we'll get there. Okay. Yeah. Then here's the photo booth. That takes photos of you by just clicking a button, so that's pretty cool. You can also put different effects on your webcam. This app here, which might be fast enough, I don't know. It has a lot of filters, so you can do all sorts of funny filters. Use my camera. Allow. It's pretty cool, huh? Whoa. Or these ones. Anyone think that Hazy Days looks like... sorry?
No, you can actually still
Pinterest? Flare. Woo.
So this is a HTML5 Instagram.
Yeah. With a lot more features. How cool is that? So yeah, this is cool.
Can you put a video element in a link tag?
Shall we ignore stupid requests? So there's many, many, many more demos. In fact, there's a whole website just dedicated to get user media demos. It's called shinydemos.com/getusermedia, which I've put in my slide deck. And my slide deck will be up soon. It's just an HTML page, right? So you can do all of this experimentation for yourself. So, right, we've done the first part. We've established a local stream. We're getting the data of our local video camera. That wasn't so hard. So now let's do the next steps. The next steps are to establish a connection with our peer and then to share the video over that connection. This is where it becomes a little bit, the standards become a little bit less stable, so things may still change. This is why everything is still, in Firefox it's behind the flags. You can only do it in nightly. In Chrome, they're starting to move it into, you know, being generally available, but be aware that the specs might still change. So what we need first is signaling methods. Interestingly enough, the signaling method, so how to find out who you're connecting to, is not standardized by WebRTC. They expect you to do that yourself, and you can do that with whatever server technology you have available. My last demo I did with WebSockets. It is possible to do with XML HTTP request. And here I'm going to show it with Socket.io. The signaling would need to share your server, so you want to share your IP address, the externally visible IP address of your computer with someone else, and of course get their IP address as well. And then you need to do the session setup to be able to talk to each other, and then you're actually talking to each other. There's nothing else in between, no server, nothing. Only the signaling, the connection setup needs a server in the middle. And for that session setup, you need to communicate which codecs and which resolution you want to use it on. So let's do that. Here's a server that I wrote, Socket.io. That's all that's required. So my little Node.js Socket.io server listens on a port. When it gets a connection, and it's of type message, it just sends the message out, broadcasts it to all the other entities that are connected to this port. That's all it does. It doesn't send it out on the same port again where it's the same app again that it got it from, but it sends it to all the others. Easy enough. Now the client side is a little bit more difficult. So on the client side, we're doing it step by step. First step is to set up the signaling channel. So here, this is the script tag that just gets us the Socket.io JavaScript. Then we're creating our socket. And we want to wait until our channel to the server is actually ready. So we wait for the connect message, and then we set, on that connect message, we set the channel to ready. Again, not that hard. Now that we've got a connection to our server, we can prepare locally our peer connection object. This is just the object that will hold all the information to talk to the other end. It doesn't actually do the connection yet. We're just setting up the object. The guys at the W3C have decided right now is to use ICE, so Interactive Connection Establishment Protocol, and STUN, which is the Session Traversal Utilities for NAT, to resolve the IP address. STUN, you can all install your own STUN server. You don't even have to go anywhere else, but you can also use some publicly available ones. I actually decided to try and implement this without using an explicit ICE server, because I'm on the local network, I know the IP address, so I'm just going to ignore that. But I still have to set ICE servers to an empty array, strangely enough. And so then I set up my peer connection object, and I hook up the on-ICE candidate. So when I'm getting an ICE candidate, I'm going to send that candidate over to the other end, so that we can communicate with that IP address. When I'm getting a stream from the other end, I'm going to put that into my remote video object that I've got on the page, the video element, so that this actually will display the video for us. So it'll happen as I get an add stream event from my peer connection. So I've just set it up to display the remote element. I'm also putting my local stream now into my peer connection, so that as soon as it has the connection, it can actually go off and send it. So that's all I need to do to set up my peer connection entity. Have I lost anyone yet? We're halfway there. We've done all the setup stuff. Any questions this far? Okay. I've either lost you all or it's all obvious. Let's assume the second. Right, so we've done all the setup. The next thing is, of course, we'll send our connection offer. What we do is we want to get both the audio and video. So we've got to create this thing called media constraints, which goes into the peer connections create offer function. Actually, I tried doing it without that, and it totally doesn't work without it. So just need to tell it, yes, use audio and video. Okay. The create offer is the function that will initiate the connection to the other side. So it's I'm sending my offer, they send the reply, and then we can start talking. So for the create offer, I have a function that gets me a session description. So it's using SDP, session description protocol, which is just a whole bunch of information in a, well, JSON object, which is required by the other end to understand what my capabilities are. So this callback, so as soon as I've done that, it gets called. And it sets my local session description to this thing and sends it over to the other end. That's what the socket send does. So the other end hasn't done all of this setup yet, right? So we've only done that locally right now. The other end gets a message, and we've set up our I/O to receive this message. It's the offer. Remember, we've just sent an offer. We've just sent create offer, and that arrives as an offer at the other end. So we need to first set up our peer connection. Same thing that we did locally. Create the peer connection object, attach our local stream, and give us a callback so that we can, when it's ready, receive the remote stream. And then we are creating another, so we're creating now our own local session description. No, here we are setting the remote description. So we've received the SDP packet from the other end, and we're setting that up for ourselves. And then we're creating the answer. And this is where they start negotiating which protocol, which video codec they use. So I've got a local SDP, I've got a remote SDP packet. They know what to do. Eventually we'll get the callback into here, the add stream. We receive the stream, and we can set up, you know, the second video. A lot of theory. Then there's all this ICE candidate stuff is happening as well. So as soon as it's set up, as they communicate, there's also an ICE candidate discussion where they're setting up the IP addresses and know all of this. This is all happening automatically. And what we get as a result is a web page which has in the source elements blobs. So they're local binary objects that are actually displayed like this. So enough talking, now we want to do it. Here's the page. And I've set up another there.
Your password.
No. I disabled that before, obviously not properly. All right, starting the local video. So on the left, we'll get our left, my right. We'll get the local video. And John will do the same. He's gone to the same URL that I've gone to, which is this one. You won't get onto it anyway because we're on our own little subnet. There's my access point. Are you there? Do you have your local stream? Can you hit connect? You. Move. What's with the bandwidth? It's pretty bad. It is pretty bad. Let's try something else. Here you go. You can see yourselves from that camera over there, going via peer connection to this, and up there. How cool is that? Endless amounts of fun. I can also hang up, then you freeze, and I can stop my local video. Right, I've got all of this code on my machine. I'm going to put that on a server. You can download it and play with it. I just wanted to show you some more cool things you can do with it. The video conference, the RTC AppSpot one. Has anyone managed to get a connection there?
Yeah.
Did you manage? Sorry?
To Crow's Nest in Sydney.
To Crow's Nest in Sydney.
Office waiting.
Oh, really? Cool. Hey, I managed to get through too. Somebody want to go to this URL? Who is the first? Because then the second one will get blocked. Let's see. Can you read that URL? Do I need to duck? 699777121. I'm waiting. Maybe. Has anyone got any messages? Connecting? Somebody's coming through. Who is the first? I don't even have some present or something. Oh, you can have this. You can play with the other app. Connecting. That one is so slow. Okay, everyone turn off their phones. What do I need to do? Dance? I'm doing the WebRTC dance. Come on, do it. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Lost patience. Where's my back button? Right, play it with your friends. Bandwidth is just not, sufficient. Other people have done some funky stuff with peer connections. This one's called WeBlend. They are putting the two connections together on one screen, but not next to each other as you would normally expect. They put them together one on top of the other and blend so that when you're in there, it looks like you're one person, but the top half is from you and the bottom half is from your peer. Just for some fun. This one's quite funny. It's called Puzzleable. It uses the video from both ends and makes little puzzles out of them, which you then, with your mouse, you have to put your own video together in the right way, and if you're faster than the other side, you win. Damn bandwidth.
Like the network cable to on the upper side.
Try that. But I want to do one more demo. No, it's okay. I can do it there. All right. Am I running out of time? Oh, that's good. You need that with the, brand new stuff like this. Everything always goes wrong. Let's see if that's faster. Oh, yeah. So here you can see that there's you and there's the other end, enemy, and it gets puzzled, and then you need to be fast and move yours in the right spot. It unfortunately doesn't work currently because they've built it towards an old version of Chrome, and the new version is the one that I fought with until I got it working. It needs the ICE stuff. That's the problem. The whole ICE communication thing is new. That didn't used to be required. It happened more automatically. Now it's more explicit. I don't like that, and I'm not sure whether we're going to keep it, but we'll see. And web meeting is just doing 2 old TVs. I don't know how well you can see that. 2 old TVs, and put your faces in the TVs with some different coloring. Yeah, but you can do all sorts of funny things. This one is also something that you might enjoy. Let me just get it from the conference network. So this is using WebRTC to do a zip video call between Chrome and an iPad. You can see that they've got the iPad there and Chrome on the desktop. And I think that's in the iPad, that's just some zip application. And because zip uses STP and all of the normal WebRTC stuff, you can actually communicate with the browser through your zip application. Pretty cool. This is something I want to bring up as one of the next things that are happening. Video recording is not something that's in the standard right now. There was a spec, then they took it out because they weren't happy about it. Right now, you can't really do video recording unless you use request animation frame and the canvas, and you make sure that it's all, you know, somehow synced. But this little app that they wrote at Google lets you do exactly that. So there's the camera, and you can record. The web party still dance, woo, woo. And then it's in a video, and you can download that video. Using web animation frame and canvas only. In the future, it should be part of the get user media stuff somehow. That works for now. Something else to play with. And that brings me to the end of my presentation. It's all still a little bit of a playground in construction. So be aware, you might be able to hurt yourself somewhere. But it's a very much of a fun playground. And lots of new ideas. You can put them in your web applications, the video conferencing. For example, Firefox have recently implemented support, and they're using their persona. How do I get out of this? Right, something's broken. That looks very bad. That's Opera. Give me Firefox. So they put it in the persona stuff, so you can actually use your connections in persona to, and you can pick them and you can directly do a video conference with them in the browser. And because they're also supporting something else that's been standardized, which is the web data connection API, so you can send data across your peer connection, just as you're doing audio or video, you can send data. You can also drop, you know, for example, your web page into that video, and your peer will get that web page, will go to that web page and can see the same web page that you're looking at the same time. They've experimented with that. It's still very new for Firefox, so you need to do all this setup stuff here in about config. But I wanted to show you how it's really working also in Firefox. So you can do a multi-host peer connection. Can you go there?
You need to get back on the other wireless.
Oh, No, well, yes. This is on the internet though. If you go on the Linux Conf.au wireless, you'll get better connectivity. So I'm in here as Sylvia. You should be Sylvia M. Did it work? Yeah, bottom one. Let me do it. Oh, now you do it. So I just need to click on one of these, but I want you to see what happens when you click. So you click on Sylvia. That didn't work. No, it didn't work. Oh, there it was for a second. Try again. Go back.